Hello and welcome to yet another video. We're going to use ccShell here. The drive is on right now and we're going to connect to it. And do you remember from a few videos ago what the GUID is? Don't worry, I cut and pasted it. So you don't have to look through there for it. Let it connect. So if we go into the viewer, these are the things that that's stored in EEPROM. You know, we got a scale factor, application code, box type 17. This is what we need to change to 18, but it won't let you change it. It's not a variable that can be changed. Same with the part number, the revision, the serial number, and date of manufacture, which is this one was in September of 2011, and of course this is our current state critical fault, and that's because it's expecting this value to be 18 and not 17 like it is. So we're going to go over to the editor, and this takes forever and a day to load. So that's loading. I will ramble on. What we're going to do is we're going to record using the logic protocol analyzer, it writing to the EEPROM. And what we're going to do is make a single bit change. We're going to go change the security bit from, right now it's set to 0, we're going to flip it to 1, and then we're going to save those changes to the EEPROM, record it, and then we're going to flip it back to a 0 and save the changes and record that. And that'll give us 2 data points where only a single bit changed from a 0 to a 1, and then we can see what the checksum does, the change that gets made to the checksum. And using that information, if you watched the video I did on the reverse engineering the battery management system on the Nissan Leaf battery pack, I'm going to use the same programs and everything that I did to reverse engineer that checksum. You can do the same thing for this, and it's almost done, and it's done. Okay. So the security bit is on the second to last page, so just scroll all the way to the bottom. And then we go up one, and maybe one more. Here it is. So this is it right here. CAN integrity monitor enabled. It's currently set to 0. We're going to set this to 1. Hit enter. And then we're going to accept these changes. That updates RAM. And then it asks, do we want to save to the EEPROM? We do, but first we need to start this guy recording. So we're going to start here. So now we're recording. And we can come back here and click Save to EEPROM. Yes, we want to. And then we get a new checksum. We hit OK. And we're going to, we can pop back over here and let this finish recording. And then we're going to have a bunch of data. And you can see in the last video I was talking about every 5 seconds or so. Or I guess it's 3.8 seconds according to the little thing. It does its little check. But what we're interested in is this right here. So we'll zoom into here. This is where it wrote to the EEPROM. I call it EEPROM because they call it an EEPROM, but it's actually a serial flash chip. And this is all the data that we're after. So they did a sequential write and put all this data in there. So yeah, we're going to go ahead and save this off for post-processing. So we're going to save everything, settings and data, and then we're going to call this, what did we do? We flipped that to a 1. Yeah, so this is use secure. You can see I've already named a couple things that I already did the water-cooled version, so we're going to change that to an A, and this will be the air-cooled version. I know you can't see that. There you go. Is that better? And we're going to save that off to the desktop. So save that. And we're ready to change this back to a 0. Hit enter. And then we're going to accept that, which writes it to RAM. And then we're going to come over here and start a capture again. And then hit save to EEPROM. Yes, we do. Success. And we wait for this to complete, and then we'll save that off as well. And then we'll have 2 copies with a single bit change, and then we can look in and see what the checksum did. So we'll go ahead, and if I zoom out here, you can see this is where it wrote. So somewhere in here 1 bit changed in all of these little writes. And so we'll just extract that data, and then we can do some comparisons. So let's save this off before I forget. Oops, wrong one. Options. Save session, settings and data, and we're going to call this not secure, and we will name that air-cooled one, and we'll hit save. So now we got everything that we need to do. So I got to do some post-processing. I won't bore you with those details. I might show some intermediate steps, but that'll be in the next video. Thanks for watching.